Hello guys, welcome to my online key fact in physics class. Today we'll be looking at the topic simple machines or machines. So what is a machine? A machine in simple terms is simply any device or a tool that enables you to carry out a work easily. Any device or a tool that allows you to carry out work with little effort is known as a simple machine. There are different kinds of simple machines. Your opener, the one you use in opening drinks, is a simple machine. Nutcracker is a simple machine. Your hammer is a simple machine. Your plier is a simple machine. Your spanner is a simple machine. All these devices enables you to carry out a work with very little effort. So in physics, we define simple machine as any tool or any device which, when you apply a force called effort at one end, helps you to overcome another resisting force called load at the other end. So, but in this, for the sake of this class, we'll be looking at terms associated with simple machines. These terms will be encountering them as we solve problems. So one of such terms is mechanical advantage, MA. Mechanical advantage. Mechanical advantage. Mechanical advantage, MA, is simply giving us load all over effort. Load all over effort, and it is written in short form as L all over E, load over effort. This formula has no unit. Why? Because load is a force measured in Newton. Effort is also a force measured in Newton. So Newton cancel Newton. This formula has no units, load over effort. That's for mechanical advantage. Another associated term in simple machine is velocity ratio, VR. Velocity ratio, VR, simply given as distance moved by effort all over distance moved by load. Distance moved by effort all over distance moved by load. That is velocity ratio. Another associated term, the third one, is efficiency. Efficiency is written as E subscript F, is usually useful work output all over useful work input. Multiply by 100. Useful work output all over useful work input multiplied by 100. Efficiency also has another formula as load times distance moved by load. All over effort times distance moved by effort. So this is another formula for efficiency. Load times distance moved by load, effort times distance moved by effort. Of course, we know that work is simply defined as force times distance moved in the direction of the applied force. That is work. Force times distance. So we know that load here is a force measured in Newton multiplied by distance. Force times distance, which is simply work. So another formula for efficiency is mechanical advantage over velocity ratio multiplied by 100. Mechanical advantage over velocity ratio multiplied by 100. So we can use any of these formulas to solve problems in machines. So we are going to look at one very simple problem, and then we look into types of machines, and then how to solve the related problems. So we have a very simple question on the board. The question says a boy applies a force of 40 Newton to move a load of 60 Newton with a simple machine whose efficiency is 80%. Determine the velocity ratio of the machines. So let's look at what we have. What we have in the question: a boy applies a force. Of course, the force he applies is the effort. 40 Newton. So the boy applies an effort of 40 Newton to move a load. We have a load of 60 Newton. Let me divide this board for space. Effort 40 Newton, load 60 Newton with a simple machine whose efficiency of the machine is 80%. The question is saying determine the velocity ratio. Velocity ratio is what we are looking for. So we know that our formula for efficiency is given as mechanical advantage out over velocity ratio multiplied by 100. So we know that the formula for velocity ratio is distance to move by effort all over distance to move by load. But in our question, we don't have distance moved by effort, we don't have distance moved by load. So that formula does not apply. That's why we decided not to bring it. So which other formula that has velocity ratio in it is this particular formula. Efficiency is equal to mechanical advantage over velocity ratio multiplied by 100. That's the formula we decided to bring because of the presence of velocity ratio. So we look at this formula, we know that from our values that we have, efficiency is there, 80%. Mechanical advantage is not here. Velocity ratio is not here. That's what we are looking for. But there's something we can determine. We look at mechanical advantage. We can get mechanical advantage from some of these values that were given to us. So we solve for mechanical advantage first, and then we come back to solve for velocity ratio. So we know that mechanical advantage is simply load all over effort, which is our formula. Our value for load is 60. Our value for effort is 40. So if we divide, we are going to have 2 here is 2. 2 into 6 is 3. We are going to have mechanical advantage as 3 all over 2. So mechanical advantage is 3 all over 2. So we can take mechanical advantage, bring it in here, make velocity ratio the subject of the formula, and solve. So we know that our efficiency is 80%. Efficiency is 80. Mechanical advantage is 3 all over 2. Mechanical advantage 3 over 2. Velocity ratio is what we are looking for multiplied by 100. So I can move this 100 to this side. Moving 100 here is a multiplier, here becomes a divisor when it gets here. So I'll have 80 all over 100 is equal to 3 all over 2 divided by velocity ratio. If I cancel out, I'm going to have 4 all over 5. So I will have that 4 over 5 is equal to 3 over 2 all over velocity ratio. So if I cross multiply, I'm going to make velocity ratio the subject of the formula. So let me divide this board further. So I'm going to have 4 multiplied by velocity ratio is equal to 5 multiplied by 3 over 2. 5 multiplied by 3 over 2. So I'm going to have 4 multiplied by velocity ratio is equal to 15. 5 multiplied by 3, 15 over 2. So I'm going to move 4 to the other side. Move 4 here. The multiplier here, when you get over here, becomes the divisor. And now our velocity ratio, 15 over 2 divided by 4. So our velocity ratio, 15 over 2 multiplied by 1 over 4. So 15 multiplied by 1, 2 multiplied by 4, we want to have velocity ratio as 15 out over 8. So my velocity ratio is simply 15 over 8. I'm pressing the value with calculator and get the value in decimal. So I believe this makes sense. We're able to learn one or two from this. This is just a very simple problem. In the next video, we'll pick another problem from past questions and